Hi Chinthaka.
Hi Boby. What do you have here?
I'm planning to have some nice lunch cooked.
It's like some kind of a stir or something. What is it?
No,
Oh,
this is the gas lighter for the.
yeah, I see some holes there.
Yes.
So and a little switch.
Yeah.
A gas lighter.
Yeah.
How does that work? I mean, it's some gas is coming out and
Gas will come out from the stove, but you need to have some way to fire it. No?
that's true.
Yeah.
Some sort of. I mean, you need to give it a small spark.
Correct.
So
Somehow we need to initiate it. Yeah. So I don't know how many of the students have actually noticed this. So, I mean, this is very clear now. I mean, from what you said, there is a plunger here. You press that.
Yeah.
At some point, you hear some tuck sound.
Yes.
Correct.
Yes.
It goes and hits somewhere inside.
Right.
And then, if you actually look at this tip, you'll see small spark going from here to here or vice versa. So if it's in the night, turn off all the light and then try, you will see it.
I get the feeling that you tried this.
I
Boby.
tried, yes, of course. So I was wondering from where this is coming.
Yeah. Where is the spark coming from?
Yeah, I don't know.
Is it some static electricity, some kind of thing, or
Also from the friction.
yeah,
But if that's the case, say, let's see if there's a humidity change, etc.
That's a
Then
problem,
it
yeah.
may not work.
Yes, true.
So that may not be the reason. In fact, you know, I tried this. I mean, I will not encourage students to do this. Of course, they will not die. But see, suppose, let's say I put my one finger here.
Okay.
And other hand finger on this.
Okay.
And then somehow if you press,
You feel a bit of a shock.
you will actually get a shock.
Really?
Yeah.
A small shock.
You will feel it. Because there's a current flowing through this. Yeah. Don't try.
Yeah.
I already tried it. So
And your advice is not to try.
yes, yeah. So that means there is some current flow.
Yes. Yes.
Of course, this is not the way something should be tested, but one thing what I noticed is there is one spark. That's it. There is no continuous spark coming out
Unless you move it up and down.
unless you do it
Press
again.
it. Yeah.
So that way, I mean, it will not harm us,
Yes.
right? So what will be inside?
I don't know.
Yeah. So I was, of course, Googling. Because opening this found to be a bit hard. Right. It's a lot of work. So they say there is some stack of things inside.
Okay.
And they say something called piezo.
Piezo.
Yeah.
Oh, piezo. Okay.
Yeah.
Yeah. What a piezo?
I don't know. P-I-E-Z-O. It's a piezoelectric effect.
Yes. I've heard of piezoelectric harvesting, energy harvesting.
Okay.
So, but how would that convert to this?
Yeah. So I was further reading. Then I got this lecture from this guy.
Okay.
So he has some nice figures. So let's say you have charges like this: positive charge, negative charge in this arrangement.
Okay.
And then if you measure this, you know, you are told if you have positive charge and negative charge, there will be some electric field and so on. So if I measure from, let's say, outside this space, will I see some charge total?
I mean, it depends the number.
So these are equal number of positive and negative charges,
So
equally spaced like this.
So then no.
Yeah. So that's what effectively there is no charge there from the outside. So there is no electric field coming out of this.
Yes.
Now let's say you modify this physically a bit,
Okay.
right? Or these distances are different here. Now it is no more the case because the cancellation will not happen exactly.
Yeah, you'll have a net charge.
Yes.
Yes.
So actually you have a small electric dipole formed there. You have a positive and negative charge spaced with very small distance.
Right.
So that means you will see an electric field there. Correct?
Okay.
So if you can somehow, I mean, if you have this kind of charge present, and then if you can dimensionally change, then you can create some electric field.
Right.
Right. Now, where is such charge present to do this?
Exactly.
Yeah.
You cannot just take it and put it
Correct.
there.
So then people found out, let's say this quartz SiO2.
Quartz.
Yeah.
Used in watches.
Yeah.
Yes. Quartz watch. I've heard of quartz
That's
watch.
true. That's true. So you have Si positive and O negative, like this, arranged exactly like you drawn earlier.
Right. This material.
Yeah.
Yeah.
There the Si and O, when O is negative. So they are arranged like this. Net charge will be 0.
Okay.
Now, if you do a dimensional change like this by applying some force, it will no more, it will cancel. So there will be some net charge. So there will be some net electric field.
Right.
Now, if you put a plate outside, two conductive plates like this, let's say this material is made of SiO2.
Okay.
Right.
Sorry, which material is made of SiO2?
The
middle material.
Middle material.
Yes.
Right. Let's say you have a layer of that,
Yes.
and then somewhere you need to collect this electric field,
Yes.
no?
Yes.
Right? Or you have the electric field, you want to convert it into voltage and
Yes.
use it probably.
Correct.
Right? So I introduce a conductive sheet here at the top and bottom.
Okay.
So if I measure from there, you will see this voltage corresponding to this electric
Right,
field.
right. Yes.
Right?
Yes. But
So
for an instant.
once you have that dimensional change, ideally it should be there forever. But I don't see that,
Right.
because that spark was there, it was there only once.
Right.
Right? Even here, we don't see forever.
Okay.
I mean, what you meant is there is a dimensional change. Let's say there is a couple of volts generated. I measure now. After some minutes or seconds, if I measure again, will it be there? No. That's the question you asked.
Yes.
Actually, it was not there. That can be explained using this simple electrical equivalent circuit of this guy.
Okay.
So, of course, we understood it's generating some charge. So, there is a charge source.
Okay.
Right. Then, see, this is also a capacitor.
Correct.
You have two electrodes separated by an insulator.
Yes.
So, definitely there is some capacitance. Then, this insulator is not a, infinite resistance.
Yes.
It has got some leakage resistance.
Okay.
So, that is what this is. So, this is a simple electrical equivalent circuit.
In parallel to each other.
In parallel to each other. So, when you press or decompress, there is some dimensional change that produces this charge. That, let's say, charges this capacitor. That's what you see there. But there is also a discharge path now. Correct?
Yes.
So, it's discharging through this resistor. That's why you are not seeing this for after some time.
Oh, I see. Because of the resistance of that.
Because of that self-discharge.
I see. Okay. Right.
So, let's say you want to use this to measure weight of something.
Yes.
I keep that.
Right.
I get an output. After some time, I don't see the weight there.
Right. Right.
There is no output.
Unless you quickly take a photo. Okay.
Yeah. So, if you want to use this as a sensor, you can only use it to measure some dynamically changing things.
So you're saying AC.
AC. Let's say there is a sinusoidally or a force which changes with respect to time. Then you can measure.
Right. What is the output that you'll get is the same as the input?
It will be a voltage in this case.
Right.
I mean, what is generated is charge.
Yeah.
But you measure in terms of voltage in this configuration.
Right.
You could use a charge amplifier to get a voltage corresponding to this. We will see that soon. So, that's all the basic idea is.
Okay.
So, it's the funda is this. The dipole is formed when there is a dimensional change. That introduces, I mean, this is one of the materials. There are many other materials. Maybe students can go through that. And then you get the voltage across these electrodes. This has got some amount of capacitance and leakage resistance. Because of this leakage resistance, it discharges through that. So you don't see that voltage for longer time there.
Right.